Welcome to my projectbazaar.com.
We will discuss about the product for precise VLSI architecture for AI based 1D 2D Daub-6 wavelet filter bank with low order count. Next we will see the abstract for the product. Discrete wavelet transform are of interested in signal and image processing due to the capability of decomposing a signal into the set of basic functions. Where draw subsidal interested in denoising, event detection, compression and reconstruction, then pattern recognition and video coding. The wavelet analysis can be used to detect the system on non-linearities by making a use of its localization characteristics. DWT based multi-resolution analysis leads to both time and frequency localization for this wavelet transformation methodology. The discrete wavelet transform has a huge number of applications in science, engineering, mathematics and computer science. Numerical analysis and functional analysis. A discrete wavelet transform in any of wavelet transform for which the wavelet are discretely sampled. Practical application can also be found in the signal processing and the acceleration for wavelet in digital communication and the many others. Daub-6 derives a wavelet filtering bank operation. This proposed algorithm to optimize the wavelet filtering bank architecture. A multiplayer-less architecture based on the algebraic integer representation for the coupling of Daub-6 wavelet transform for 1D, 2D signal processing and image processing is proposed. This architecture improves the previous designs in a sense minimizes the number of parallel to input adder circuits. This algorithm achieving the brute force numerical optimization of the algebraic integer representation of the work. The proposed architecture furnishes the exact computation up to the final reconstruction step, which to algebraic integer represent the fixed point and compared with the recent work. The architecture reduces the number of adder in our proposed methodology. Next we will see the flow diagram for the product. The original images to apply to the process and to add the noise for the pre-processing step, then add the noise for salt and pepper noise in this certain ratio, then noisy image to apply to the MATLAB process, then acquiring the binary points for the noisy image, then the noisy image to apply the Daub-6 filtering architectures. The Daub-6 filtering architecture obtain the random points for the noisy image, then apply to the DWT transformation. This DWT transformation to passing the Xilinx software. Then the pre-processing to apply to processed by the MATLAB process. Then the MATLAB results in stored by the one of the test architecture. The text results to apply the input for the Xilinx software. Then the Xilinx software to get the text and write the text integer values. Then apply the DWT transformation process. Then the DWT transformation process, one of the encoding work. The encoding work obtain the random points and to apply the DWT transformation. The transformation is mainly considered for the three processing work. First of all the reconstruction, then the decomposition and transformation thresholding region, then to reconstruct the original input image. Then three processes to be applied by the one by one ordering technique and to develop the Xilinx software. Then they apply the inverse DWT transformation to reconstruct the original input image and decode the random point section. The random point section to write the data for again to apply the text for the MATLAB process. The MATLAB process to resize the image and to reconstruct and to display the original noise removal image and to apply the MSE and BSNR value. The MSE value is mean square error and the BSNR means peak signal to noise ratio. How to remove the images, how to remove the noise from the original image to reconstructed image. Then we calculate the final results. And finally we see the output for the product. Just we select the main file and just open the main function Then create the main function, the pre-processing step to apply the MATLAB function, and the another steps transformation steps to apply the Xilinx architecture. We just open the function, then run the file. We select the any one of the images, just we apply the noise input for the process. The noise result is to be applied. And to go to the Xilinx filtering architecture block in ISC project list, then create the Xilinx project. Thus the nice input images to be applied by the Xilinx ISC project list. Thus the text document to apply the input for the Xilinx ISC project. Then open the Xilinx ISC results for our process. This the input images for our the architecture. Then open the Xilinx ISC project navigator. Then apply the text input to the Xilinx ISC project navigator. Then select the filtering signal and to select simulate, then calculate the simulate behavioral model functions. Then run the behavioral model functions and to run the simulation process. This process to activate the filtering work for the our text to result. Then the text result to write the any of the text and to apply the MATLAB functions. Then create the ISM project navigator. Just we activate the input signal processing for our architectures. Just to deactivate the reset and activate the enabling function. Just we activate the process only. Then close the our process. Then close the results and to close the all images. Then to press any key to display the output, which select the command window. Just we enter the process and retrieve the original output for our the process. Then calculate the BSNR and MSE value for the our project functions.